Hey, today's subject is cellar walls. We are almost finished with the building, and we are talking today about this part here of the building envelope, which is in direct contact to the surrounding earth. So what is especially problematic is water and in which form it occurs. So we have splash water here, about 30 centimeters from the ground on. Then we have sewage water arriving at the building, and we might have a groundwater level. So then we can have capillarity upwards from the groundwater level. So we have to deal with these types of water in the ground. So the groundwater level will interest us especially when it is higher, the basement level. Capillarity can be cut by introducing a capillarity breaking layer, like for example gravel. Sewage water here has to be kept away from the building by creating a zone where it can descend, and then by a drainage pipe has to be taken in the sewer system. We will start by determining the building's position with the better board, then dig out our foundation. Then I have the walls on the foundation. I might have some gravel here as to cut capillarity. I might as well have a sort of crawl space which fulfills the same function as the gravel, and then ground floor plate. We are looking at this wall here, and what I would do to treat the sewage water is to keep it away from the wall with, for example, peripheral insulation. Peripheral insulation would contain the insulation itself, and then in the insulation there would be little canals on the outside and a felt on the outside. This is the side that is connecting to the cellar wall. And I would need ceiling compound on the cellar wall, and then the cellar wall itself. All of this would be here, the ceiling compound on the cellar wall. You have seen that we introduced a drainage layer here, and then all of this has to be connected to a drainage pipe. So for the drainage pipe, there are different solutions. It can be embedded in concrete, or it could be embedded in gravel. Second case, it would have holes on all sides, and in the first case only on the top. So this is this thing here. This thing has to be put in about 1% slope, and then it will be connected to the sewerage, passing by a control shaft, sort of manhole, where we can control that the water flows freely. Afterwards, I'm going to put a felt in the ditch as to make sure that the gravel that I'm filling in afterwards will not be littered by earth filtering in and taking away its filtering quality. And after having filled the gravel in, then I will finish this felt against the insulation, and then I can take the pile of earth that I have put aside earlier, have blend infill for the rest of the ditch. This was for sewage water. There's a lot of plastic products being used in the building process. You have the protective plastic film put in front of the cellar insulation. The green plates behind that are waterproof insulation. And behind that you have air tightening film around the openings to be sure that there's no air exchange between the interior and the exterior. So behind me you can see the felt front of the drainage layer here, and behind that is the part of the exterior wall that is touching the earth. So this is where we need the drainage layer. Now we are treating the case where I would have groundwater. And as you remember, this groundwater would fill the ditch. So what I'm doing here is to install pumps that would pump out the water next to the ditch and thus lower the groundwater level in a way that it cannot fill the ditch anymore. And then I can have a granular subgrade course and erect the cellar on this granular subgrade course. In earlier days we had sort of tub-like construction where I would put a waterproof foil inside of a tub, and then I would build a second tub inside of that, which would then be my building. So in German that would be the schwarze Wanne, and in English it's sort of waterproof foil between two concrete walls. Today we have a simpler construction than this. So today I'm capable of having waterproof concrete. That's very interesting, as it allows me to have waterproof concrete tanking. Then the groundwater level would be kept away by this waterproof concrete wall. We add silicone to the concrete matrix and thus it becomes waterproof. Where we have to be attentive is where we have concrete joints, because the concrete joints would let the water in if not treated. So we have special profiles that we insert at these joints. So the sense of these profiles is to waterproof the joint and to lead the water the longest way possible around this silicone profile so that it can waterproof our basement and it would not become a bathtub. So in this case I don't need the drainage system anymore because it's underwater. So this is wrong, and I don't need it because all of this is perfectly waterproof, should be at least. Now another problem could be the insulation. There are special insulation materials, XPS, extruded polystyrene material, and this exists in a highly compressible quality as well, so that I can insulate on the outside, which is always the optimum, or here on the building site also from the outside, because otherwise I would be obliged to insulate this from the inside, which is less performant because I have connections. I'm next to a particular ditch where the earth has been contained with a wall consisting out of round concrete piles, and then the building has been built inside this basin. You see the interior concrete wall. It's watertight concrete, as you can see at the yellow element. In front of us is a wall before the exterior formwork is brought on. Here, so you can see the reinforcement mats and bars and the interior formwork, and afterwards concrete will be poured in from above. In the middle of a construction site with reinforcement mats here made out of rebars. Here's some more rebar on the side, and the bricks as they are delivered to the construction site on pallets, so that you don't have to carry them one by one as was the case before.